All right, so we're going to talk about solving systems of linear equations. And whenever you have a system of linear equations, all that means is that you've got more than one. More than one linear equation is a system. In this class, we're only going to deal with two, and we will very lightly touch on three equations at the same time, but predominantly two is what we're going to focus on. So when you have two systems of equations, the way that we show they are a system, that they go together, is with that symbol right there. And then next to the symbol, excuse me, we will write our two equations. Let's do 2x minus 3y equals 6. And then how about x equals 2y? That seems pretty good. So our goal here, when we've got a system of equations, is real simple. We've got one question that we want to answer. And the one question that we want to answer is, if I were to graph both of those lines, what point would they cross at? Or at which point would they cross? You should never end a sentence in a preposition, kids. At which point would they cross?
The x-axis, right?
I don't know, maybe. Now what I'm saying here is I think probably these two equations have one point in common. I think probably one of them goes up and one of them goes down and they cross somewhere in between. I might be wrong. They might not cross at all. But I'm going to assume that they cross, one time, and I want to know where is that one spot. So before I show you how to do that, let's do something a little simpler. Let's say that I'm telling you I already did this problem. I already found the spot where they cross. They cross at the point 12, 6.
Do they?
I don't know.
Both of them, or we just talking about?
Well, if they cross at 12, 6, what does that actually mean?
Oh, that's.
It means the coordinate 12, 6 would have to work, I'm using air quotes here, would have to work for both of these equations. Meaning this line would have to go through 12, 6, and this line would also have to go through 12, 6. Now I'm telling you it's 12, 6, and you should doubt that because I just made it up. Is there a way that you could verify and see whether or not I'm telling the truth? Well, the first number is an x, and the second number is a y, so why don't we just use these as an x and a y, and go up to each one of these equations and replace the x and the y with those numbers. So for example, this one was 2x minus 3y equals 6. Instead of 2 times x, let's do 2 times my x value, which was 12. Minus, and instead of 3 times y, let's do 3 times my y value, which was 6. And let's see, when I plug those in, does it equal 6? All right, so 2 times 12, 24. 3 times 6 is 18. And then 24 minus 18 is 6. So what I end up with is 6 equals 6. Now what does that tell me? It's correct for what?
It's going to go through the point.
It's what's going to go through that point?
That equation.
Just that equation. For this to be a system of equations, both of them have to go through that point. So now I need to do the same thing with this equation, x equals 2y. So it'll be, instead of x, 12 equals 2 and times y, which is 6. So this would be 12 equals, and 2 times 6 is 12. That's also correct. What does that mean?
True.
That is true. So what this means is that set of equations, 2x minus 3y equals 6 and x equals 2y, both of those equations go through the point 12, 6. What this tells me is that 12, 6 is a solution to this system of equations. Solution meaning it is a point that both of these equations have in common. Meaning if I were to graph them, both of them would go through 12, 6. All right? Let's try another one. Put your little Actually, I have no idea what this thing is called. Anybody know what that symbol's called? To me, it looks like a Alfred Hitchcock profile. You know, like Alfred Hitchcock Presents, and his shadow would go up on the screen. You kids have no idea what I'm talking about.
I do.
Thank you. Thank you. So here's my system of equations. And let's suppose that I have decided to solve these. I don't need any of your help, you guys. I got this one covered. I've worked it out. I've graphed them. And the spot where they cross is -1, 2. Do you believe me?
No.
No? Why?
Where's the proof?
Where's the proof?
He wants evidence. He's not saying.
Well, I mean, I admire that you want evidence, but why is your first instinct no, that you don't believe me? Why don't you believe me until you have proof that I don't? What happened to innocent until proven guilty? I thought this was America.
No, this is communism.
Wow. Communism isn't even a place. So, this is my x, and this is my y. I'm going to go through both of these equations and replace the x with -1 and the y with 2. So x plus 2y is going to become -1 plus 2, and instead of times y, it'll be times 2 equals 3. Okay, let's go ahead and work it out. So 2 times 2 is 4. From the point, the -1, 2 is what I said I thought the solution was. And you're just checking to see if I know what I'm talking about.
Okay.
I probably do. I'm pretty great at this. -1 plus 4 is 3, so I end up with 3 equals 3, which tells me what?
Wrong.
True.
It's true for that equation. This equation goes through the point -1, 2. But for it to be a solution to a system of equations, both equations have to go through that point. So let's try it again with the 4x minus y. So 4 times x, which is -1, 4x minus y equals 6. So 4 times -1 is -4. And -4 minus 2 is -6. It doesn't work for that one, meaning this equation does not go through the point -1, 2.
Not a solution.
So -1, 2 is not a solution. It works for one of the equations, but for it to be a solution, it has to work for both of them, and this one doesn't.
See, you lied to me.
I did lie. Yeah, you were right to disbelieve me. I'm sorry that I led you astray. I mean, I'm sorry-ish that I led you astray. I'm not like crazy sorry about it. You'll get over it. It'll be fine.
This is X and Y.
Okay, so fine. If I gave you a coordinate and said like, is this the answer, yes or no? You could tell me by doing this, but I'm probably not going to give you the answer most times, right or wrong. Most of the time, I'm going to ask you to find the answer. So let's talk about how to do that. Now we are going to learn 3 different ways to solve a system of equations. 3 different ways, and we're going to do them all at this class. The first method I'm going to show you is how to solve a system by graphing. Okay, so here we go. Let me give you a system. -x plus 3y equals 10. And the other one will be x plus y equals 2. So to solve a system by graphing, one of the first things that you need to do is graph it. We talked last week about how you can graph stuff without making those t-charts. We have to find all the coordinates. The way that we learned was you can graph them by putting them in slope-intercept form. So let's do that. Let's take the top one, -x plus 3y equals 10, and let's put it in the slope-intercept form. How do I do it?
Negative X over to the right,
By doing what?
adding x,
That's a good idea. Plus x.
That equals 2.
which is 3y
So
equals
3y.
x plus 10.
There we go. Good man.
And 3, divide 3 by all of them.
Mm-hmm.
Y equals 1 over 3 plus 13,
1/3 x plus, not 13.
or 3.
10 divided by 3 is 10/3.
Oh, yeah.
Or, I guess, 3.3333 if you hate happiness. You could write it that way. All right, there we go. First one's ready to go. So I'm going to get my graph paper here. Now, what problem do we have right away when we try to graph this?
Fraction.
Yeah, my y-intercept is what?
1/3.
10/3, which seems sort of bad.
Yeah.
Like, where would 10/3 be? Like, it's like a little more than 3. That seems kind of gross.
You
I think
change that to something?
well, I could change it to 3 and 1/3, but I still have the same problem of like graphing a 1/3, which is sort of gross to me. So when you put it in slope-intercept form and you end up with a fraction for
Just use the top.
the y-intercept, just change the number. I feel like I'm going to make a t-chart anyway, even though I put it in slope-intercept form to avoid it. I feel like I'm still going to do it just because this looks nasty. So what I know is the y-intercept is 10/3, so 0, 10/3 is one of my points, but that's not really helpful to me. How do I graph 0, 10/3? It's not like the most helpful number. But is there a number I could plug in for x that would give me something kind of nice?
3.
If I plugged in 3, I'd have 1/3 times 3, which is 3. Plus 10/3 would still be something awful. Let me show you what I mean. What if I plugged in for my x value -4?
You just picked that randomly, right?
Nope, I didn't. You're going to see why I picked it here in just a second. If I replace the x with -4, my y would be 1/3 times -4 plus 10/3, right? 1/3 times -4 is -4/3 plus 10/3. And -4 plus 10 is 6, so this is 6/3, which is 2. -4, 2 is one of the coordinates there. That worked out really nicely. It's a really, really nice way to do that. What is another number I could plug in that would work out real nice like that?
-8.
-8? Let's try it. So that would be 1/3 times -8 plus 10/3. That would be -8/3 plus 10/3, which is 2/3.
No, that works.
Yeah, that's kind of upsetting.
Man. Please never have to find that if it doesn't work in a fraction?
Yeah, I want something that gives me whole numbers just because it's easier to graph.
Okay.
So when I plug in an x, I get a whole number for the y.
I was thinking about like 6.
+6?
Yes, positive 6.
Well, let's think about that. 1/3 times 6 is 6/3, which is 2. So I'll have 2 plus 10/3, which is still going to be a fraction. I don't know. How about 2? That would give me 1/3 times 2 plus 10/3. That gives me 2/3 plus 10/3, which is 12/3, which reduces to 4. So 2, 4. There we go. Now that took a lot of work, but I got 2 coordinates that are whole numbers.
So that's what's going to happen. If you run into a fraction, you just got to find the coordinates that would just make it simple.
That's going to happen if your y-intercept is a fraction. If my y-intercept had been a whole number, I'd be good to go. Since the y-intercept was a fraction, I had some problems. All right, so let's put these 2 points on there then. So negative 4, 2. Right there. And 2, 4. Right there. And once I get those points on, I will go ahead and connect the dots. There we go. Nailed it. Let's go to the other one. The other equation we had was x plus y equals 2. This one's going to be a lot easier to put into slope-intercept form. What's the one thing we have to do to put it in slope-intercept form?
Just subtract that.
Yeah, just subtract x.
Okay, see now, I totally forgot what we're doing now.
We're trying to graph both of these equations. And the
Oh,
reason we're
okay.
trying to graph both of them is because the spot where they cross, that intersection, is the
Right.
solution.
Oh, that's okay.
This one's really easy. I don't have to make a table for this one because the y-intercept is a whole number. What's the y-intercept?
2.
Y-intercept is 0, 2. And what's the slope? Negative 1. Great. Okay, so on the same graph, the one that I just did, I'm going to put my y-intercept of 0, 2. And then a slope of negative 1 gives me a rise and run of what?
Repeat your question.
What's the rise and run if the slope is negative 1?
0 over 2. Oh, what's the
Yeah, down 1 and over 1. Down 1, over 1.
Yeah.
Down 1, over 1. Let's go ahead and connect these. There we go. Hey, look, those two cross. Where do they cross? Right there. What point is that?
Negative 1 over. What was it?
Negative 1, 3. So negative 1, 3 is the solution. If you weren't 100% sure on your graphing, if you thought, well, I might have messed up on that tree diagram over here. That part confused me. I might have messed that up. I'm not completely sure negative 1, 3 is the right answer. I might have messed up. How could I check my answer?
By doing the graph.
We just did it a few minutes ago. If I think it's the answer, how do I check and see if it is? By plugging it in. So one of the ways I can verify the answer is if I take the original equation, negative x plus 3y, and replace the x with negative 1 and the y with 3. So negative x plus 3y equals 10. Negative 1 is 1. 3 times 3 is 9. 1 plus 9 is 10. So it works for the first one. Let's check the second one. X plus y equals 2. So x plus y equals 2. And negative 1 plus 3 is 2.
How did you get negative 1 and 3?
Negative 1, 3 came from the graph. It was the spot where the two lines crossed. That was the coordinate where they intersected.
Man, I really look like yours. See, when you went negative 1, what do you mean rise over run? Would be negative 1 up?
Right, so the slope was negative 1. When you want rise over run, you just turn it into a fraction. What's negative 1 as a fraction? It's negative 1 over 1.
Okay, so negative 1.
So the rise was negative 1,
So that would be going down, right?
and the run was 1, yeah.
And then the,
So down 1 and over 1.
and the over one to the right, right?
Always to the right.
And then you what is it, 0, 2?
Right, this one was way easier because the y-intercept was 2, which means I could just put a point on 2 and then use the slope to get my other point. This one was a nightmare because the y-intercept was a fraction, which is pretty gross. I mean, I know you're not supposed to judge things based on what they look like, but that one's pretty nasty. All right, let's try another set. So the good news here is that one of these is already ready to go. Which one's ready to be graphed right now?
Y equals
Yeah, y equals -5 is good to go. What does that look like?
0, -5.
0, -5 is the y-intercept, and then what's the slope?
Undefined.
Why do you hurt me? X equals is undefined.
X
Oh,
equals
sorry.
1,
Y equals is,
1 rise over 1 rise.
yeah, you're doing the hand motion. It goes like
It's
this.
horizontal, yeah.
It's horizontal, so the slope is, it's less than 1, but bigger than -1. It's the number of girls who said they would go to prom with you. -3. 0. The slope is 0. So this one I can graph right off the bat. The y-intercept is at 0, -5. And it's a flat line, meaning slope of 0.
Yeah, I'll take 0 over -3.
0 is an improvement over -3. That's true. Perfect. That one's good to go right now. The other one's going to require a little bit of work from us. That's all right. -4x plus 3y equals -3. And then we want to put that in slope-intercept form. So what do we do? Say it again.
X and Y.
I want to get the y by itself, so it's in slope-intercept form.
3y plus 4x minus 3.
Right, I want to add the 4x to both sides. Plus 4x. So that gives me 3y equals 4x minus 3.
And then divide term by 3.
Everything gets divided by 3. So the slope here is going to be kind of nasty. It's going to be 4/3, but that's okay because the y-intercept's a whole number. -1. Perfect. I love it. So what's the y-intercept for this equation?
-1.
0, -1. And the slope is
4/3.
4/3. So the rise is 4 and the run is 3. Good. So on the graph, I'm going to put my point at 0, -1. Right there. And my rise is 4. 1, 2, 3, 4. And the run is 1, 2, 3. There's my second point. 2 points is your minimum. Might want to do 3 just to make sure your graphing skills are strong. Make sure you didn't make a mistake. And there we go. Looks like they cross.
-3 over -5.
Looks like right there.
Right?
-3, -5. That's what I got. Hopefully one of the things you're realizing here is if your graph is not just perfect, you're going to have a bad time. Luckily, you're in good hands, kids. I don't know how to do any graphs except the perfect kind. -3, -5 is the solution. I could check this by plugging it back into the original equation, or I could save myself some time and just take the math teacher's word for it. I think we should go with the second one.
That's what happened last time. You were wrong.
Yeah, I've been wrong before. Well, that's a lie. I haven't been wrong before. One time I thought I was wrong, but it turned out I was okay. All right. Let me throw you a curveball, as they say in want to say cricket. Cricket. Is it? I don't know sports. I'm gonna throw you a curveball, I used to say to my sports friends when I rolled my saving throw versus ladies. So let's see where these two cross. Neither one of them is in slope intercept form, so we're gonna have to do that. Luckily, both of these are just one step away. One step away from glory. So the first one, 2x plus y equals 7. What's the one step that's going to put that bad boy in slope intercept form?
Move to 2x.
Yeah, let's subtract 2x. That is a good... man, you guys are so good at algebra. I can tell your algebra teacher is incredibly handsome. There we go, slope intercept form. Boom. What's the y-intercept? What's the y-intercept?
7.
Why do you hurt me? 0, 7. And somebody give me the slope as a fraction.
2 over 1.
Negative 2 over 1. Good. Cool. So, let's go back to our graph paper.
So 0, 7.
0, 7. 3, 4, 5, 6, 7. And then negative 2, 1. So down 2 and over 1.
Wait, is that on that point, right?
Hmm?
On that point, is that where you do the rise over 1, right?
Right, from the y-intercept, I went down 2 and over 1. Like so. Well, let's connect them. There we go. Nailed it. Okay, and let's follow it up with our second equation, 2y equals negative 4x. That one's also just one step away. What's the one step to get that slope intercept form?
Just divided by 2.
Just divide by 2. That's a good idea. So y equals, and negative 4 divided by 2 is negative 2. Negative 2x. So what's the y-intercept here?
0.
0, 0. And the slope as a fraction is?
Negative 2 over 1.
Okay, negative 2 over 1. Hey, same as the last one. What a coincidence. All right, so 0, 0. And then our slope down 2 and over 1. What? Those don't cross? Well, I mean, maybe they do. Maybe add a bigger graph. Like maybe they'll cross eventually down here somewhere. Might need a bigger graph. Who brought a giant sheet of graph paper? Are these going to cross eventually?
No.
No. Did I need to graph them to know that they weren't going to cross, or did the math tell me that?
The 0, remember how you talked about the girls and the boys or whatever? Right? And then because of the same parallel deal that you talked about?
Yeah, why are they parallel?
Because of you talked about the girls with the boys can only have with 1.
Oh, you're thinking of what's a function?
Yeah. Oh, is that it or no?
No. Parallel lines have the same slope. What does it mean when lines are parallel? Where do they cross?
Never.
They don't. So this one has no solution. I didn't actually even need to graph these to know that there was going to be no solution. I mean, I'm glad we did because graphing is fun and I think we all enjoyed it. But I didn't need to graph it to know that there was going to be no solution here. Okay. All right. Neither one of those is in slope-intercept form either, I'm sorry to say. Easy problem to fix. Really easy on the second equation, so let's do the first one first and just get it out of the way.
Negative y minus x plus 3.
Right, so minus x. Negative y equals negative x plus 3. I don't really like that the y is negative.
So you divide negative by all of it?
Right, divide everything by negative 1.
Negative 1.
Good plan. You are a smart guy. Dividing everything by negative 1 has the effect of just changing the signs on all of it. So positive y, positive x, negative 3. So the y-intercept is 0, negative 3. And the slope as a fraction is
Negative 1.
Negative 3
Or,
over
yeah,
1.
1.
Negative 3 over 1.
negative 3.
One.
Negative 3 was y-intercept.
Would be 1/3.
Why are you putting the 3 in with the slope? 3 is the y-intercept. What number's in front of the x?
Oh, 1.
1 is in front of the x, and as a fraction, 1 is 1 over 1.
So why would we make that a fraction 50?
So we've got rise over run,
Oh, okay.
just so we can see rise over run. Now, I'm not going to graph that yet because I learned my lesson on the last problem, which is that I could have got away without graphing it at all if I just paid attention to the slopes. So before I graph this, I'm going to do the second one. I learned my lesson when my math teacher tried to trick me on the last problem. All right, so let's do this one.
Okay, add x.
Mm-hmm.
Those are already the same
No,
thing.
they're the same.
So it's parallel, right?
What's the y-intercept?
0, negative 3.
And the slope as a fraction? Okay, so some of you said, and I think it's a really good thought, hey, these are parallel because look, they have the same slope. But they're not parallel.
What?
They're not parallel.
They cross.
They do cross.
Oh.
Yep. As a matter of fact, they cross a bunch.
They're on top of each other.
Yeah, this is the exact same line. Now, if you go back and look at the parallel ones, those weren't the exact same line because the y-intercepts were different. 0, 0, and 0, 7. Different lines, same slope. These are the exact same line, same slope and same y-intercept. So if I graph this one, I would put a point at 0, negative 3, and then up 1 over 1. And if I graph this one, I would also put a point at 0, negative 3, and go up 1 over 1. They'd be right on top of each other. Now, the goal with a system of equations is to answer the question, where do these lines cross? Where do those lines cross? Everywhere. So what's the solution?
Infinity.
Any number you can think of,
All numbers.
any x number you can think of,
All x.
they will have the same y value. So how many numbers is that?
Infinity.
All of them. Well, that's a lie. It's not all of them.
It's that little.
I shouldn't say it's all of them because not just any x and y will work. But I can plug in any x I feel like and get the same y, and I can think of a lot of x's. I can think of like infinity x's. I don't like to brag, but if I wanted to think of infinity x's, I could. So it would be incorrect. I misspoke when I said the answer is all of the solutions because it's not every point. But just because it's not all of them doesn't mean there aren't infinity of them. So there are three possibilities when you're solving a system of equations. And this is true for graphing, which is what we're doing now, but it's also true for any other way that you could solve a system of equations. Three possibilities. Possibility number one, there is one solution, meaning the lines cross in exactly one place. This happens when they have different slopes. If your lines have different slopes, they are going to cross one time. Period. End of story. In Euclidean geometry. Don't worry about it. If they have different slopes, they're going to cross. Number 2, they might have no solutions. This is if they have the same slope, different y-intercepts. And when they have the same slope and different y-intercepts, this is what's known as parallel. And our last possibility is that there are infinite solutions, which is a lot of solutions. Infinite is like over a million. This is when they have the same slope and the same y-intercept. And this happens when it is the same line. Meaning they overlap. One line on top of the other. So before we wrap up solving by graphing, let's talk about some of the advantages and disadvantages. One of the advantages is it's pretty easy in general to graph something. At least it was pretty easy to graph all these. Putting something in slope-intercept form is not that hard. Plus, having a picture of it's really useful. It's useful to be able to visually see it. Now, the disadvantages, there are a couple. One of the disadvantages you saw earlier, when you have a problem with a fraction y-intercept, it can be kind of a nightmare. Another disadvantage is if your graphs aren't perfect, if your graphs are off by a little bit, it's going to be hard to see where's the point that they cross. And then the third disadvantage, which is not something we talked about, is what if the solution exists, but it's giant? Like what if the solution is 35, negative 119? I can't fit that on a sheet of graph paper. So there are some disadvantages to solving something by graphing, which is why we need some other methods to do it. And we're going to talk about those other methods here in just a minute. But does anybody have any questions over graphing before we move on to the next thing?